I'm Heather Goldstone. I'm Chief Communications Officer with Woodwell Climate Research Center, and I just wanted to take a moment to welcome everybody. Thank you for your time and for joining us today, and to give you a little bit of background about Woodwell Climate before I hand it over to Alex and Chris and Jen for the main event today. I wanted to start just by pointing out the name Woodwell Climate Research Center. Some of you may have been familiar in the past with Woods Hole Research Center. We are one and the same. We changed our name last year in August of 2020, primarily to make really clear, first of all, that we're laser focused on climate change, and also to really honor and center the working philosophy of our founder, George Woodwell, who founded the center 35 years ago with the idea that science needed to not just passively be available to inform societal decision making, but really needed to be integrated with and embedded into decision making. And 35 years later, that's still very much how we work. I think it's one of the really unique things about our organization. And we have partners who are leaders in government, in business and finance, in faith communities. And I'm really excited to have you guys on here with us today, because you're such important influencers for the American public. I'm always amazed, as someone who has spent my entire career essentially embedded in a science community and doing science communication in some form, to realize that for many Americans, their doctor and their weather forecaster are their two closest connections to science in their lives. And as we've just been talking about with the really tragic situation still unfolding in Texas, and as we've seen just repeatedly over the past year with wildfires, with hurricanes, a record hurricane season, and extreme weather damage tallies in the billions and seemingly rising every year, that the impacts of climate change are no longer theoretical. They're no longer, something that happens sometime in the future or somewhere far, far away. The impacts of climate change are really here and now. And as meteorologists, you really have an amazing opportunity to help people connect the dots and understand the role of climate change in these extreme weather events and in their daily lives. So, thank you for your time, particularly this week. I really hope, and I think that this hour will end up feeling not like something that is pulling you away from breaking news coverage, but really helping you to develop and deepen and contribute to the stories that you're telling about our winter weather right now. So with that, I will hand it over to Alex Goldstein of 90 West, who is a communications advisor for Woodwell, and he can get things started. Again, just thank you so much for being here.
Awesome. Thanks so much, Heather. And thank you everybody for joining. Like, what a week to be doing this. And thank you for putting up with my emails and many calendar invites and all of those things. Just like really thrilled to have you on here. As Heather mentioned, I serve as a communications advisor to Woodwell, and just wanted you to know who I am, because I'm really thrilled to be a point of contact for all of you. If you ever need, for any of your coverage needs, to have a sort of climate science voice, or just to run some ideas past folks on background or anything else, please do not hesitate to be in touch. I will drop my contact info into the chat, and you also have my email. But we are really here to be a resource. And in addition to Dr. Francis, there's a lot of really great folks at Woodwell that are eager to help supplement your coverage however is beneficial, and you can always call on us. And I pride myself on really quick turnaround. So if you need something for an urgent story, you can reach me 24 hours a day at my email, and I will do my best to connect you with the right person who can help you get what you need. Today's session is 100% on the record. It is, we do have lots of time for Q&A. To make life easy for Chris, I think what we'll do is, if you have questions that pop up as we go, you can just drop them into the chat, and Chris can pull them from there. And if we also want to get a little conversational later on, we can also do that as well, but that'll just help Chris sort of prioritize which things to get to. And with that, I'm really eager to turn the mic over to Chris Gloninger. Chris is a meteorologist at NBC 10 here in Boston, and I love to see him on my TV screen every day. And he really has been a model, and I'd say a pioneer of, doing coverage that really can connect the broader climate issues at play with our day-to-day weather coverage. He's done a lot of that coverage here in Boston, and we certainly love to see it. And we're really grateful to have him as our moderator today for this very timely conversation. So Chris, floor is yours.
Alex, thank you. And Heather, thank you for inviting me to join this and to moderate this event. Just a little bit of a background of what I do. Again, I'm a meteorologist, but I became a climate reporter on top of my weekend weather duties here at NBC in Boston. In 15 years, it's remarkable seeing the transformation of covering climate change. When I pitched it to a news director 15 years ago, they told me absolutely not. And then it went into you need both sides, in which case we all know that that's a false balance. And I had an executive producer who was on board 2 years ago. We just had our 60th climate story with our weekly series last night, and it's been tremendous. And I think seeing the diverse group of people here from different affiliates and station ownership groups, it's important and a testament just how important it is to cover climate change in our weathercasts, if you are able to do news segments. And being a weekend meteorologist and doing this on the side, most days are 7-day work weeks. It's a passion of mine, but Alex and the team make it so much easier to stomach those 7-day work weeks, because I can say, hey, I want a story that sums up 2020 and the number of billion-dollar disasters. I need an expert who can talk about storm surge inundation modeling and areas hardest hit and what projections are. And the team has been tremendous. So I thought this would be a great format and a great opportunity for you to meet this team, and they are awesome resources, and I hope that you use them. So let's get to Dr. Jennifer Francis. She has been in the spotlight a lot in this last week to 2 weeks. A lot of her research is with the Arctic and the undulations in the jet stream, sending these Arctic surges in the polar vortex equatorward, and obviously it has come with some serious consequences down across Texas. Dr. Francis, thanks for speaking with us today. I want to start right out of the gate with, what do you believe are the biggest climate stories of 2021? What's happened so far and looking ahead at the rest of the year?
Great. Yeah, well, thank you so much, Chris. Thanks, Alex. Thanks, Heather. It's great to be here with all of you. And as Heather said, I really believe that you all have a really unique opportunity to connect with the public. And as Chris said, it's just hasn't been that long that many, producers of TV shows and radio channels and so forth have even allowed their meteorologists to talk about climate change. So I too sense a big shift in the conversation, and a very welcome one at that. So here we are only in February of 2021. So looking forward, it's already been a wild year. Last year it was a wild year. It's very tough to predict what this coming year might bring us, but I think it's very safe to say that it's going to be another very interesting one. We're already expecting La Nina to stay in its negative phase, for example, perhaps weaken. It's, the ENSO cycle is pretty tough to predict still, but most of the reliable models seem to suggest that we're going to be continuing with a La Nina, which you all know is one of the factors that is most influential in the Atlantic hurricane season. So, just being in that La Nina situation tilts the scale towards an active hurricane season. It'll be really interesting to see, what the centers who predict the Atlantic hurricane season come out with, but that is certainly one of the most important factors. And on top of that, we know that the ocean temperatures in the North Atlantic are still running a fever, basically, especially along the East Coast and in the main development region in the tropical Atlantic. So, I think it's pretty reasonable to expect this hurricane season coming up here to be another active one. We're still seeing the Arctic running a major fever as well. That ice up there is, it's actually grown to near normal extents in most areas, but it's very, very thin. And so a lot of the heat that's in the Arctic Ocean is much more able to penetrate through that thinner ice cover and get up into the atmosphere. And that's why we're seeing I saw a prediction for like 10 days from now for what the Arctic near surface air temperature is going to be. And it, you know, there's this huge swath of 20 degrees Celsius above normal. I mean, that is wild. And as you all know, as we disrupt that poleward temperature gradient, it's likely that there are going to be further impacts on the jet stream. You know, those are really hard to predict, and it's very regional. But I think it's probably safe to say that the spring is also going to bring us some interesting, I call them interesting, you know, could be extreme, certainly worth talking about, some weather events that will probably be very unusual, but, you know, it's really hard to pinpoint where and what sort and, you know, and when. You know, other than that, I think it's pretty tough to make any huge predictions. We know the Western US is still running way behind on its rainfall. So unless the spring months, which often do bring a fair bit of rain to the West Coast, unless we get a lot of rainfall, precipitation, especially snowpack, we're going to be looking at another serious situation out there with potential for more big wildfires if we don't bring that snowpack back up closer to normal levels. I think, you know, as far as predictions for this year, I think that's about, you know, as far as I could stick my neck out.
Dr. Francis, when is it the right time for meteorologists to attribute weather events to climate change? And how has attribution science allowed us to connect the dots between day-to-day weather and the climate crisis?
Well, there's never a wrong time, in my opinion, but it has to be described properly. We can't, as you all, I think, well know, you can't say that, okay, this particular event was the product of our changing climate. But what we can say is that this event that we just experienced, or this one that we're forecasting to occur, is consistent with the research that that we expect to see happening more often, perhaps, in this globe of ours that's warming at our hand because of burning all the fossil fuels and cutting down the forests. So I think, you know, it's always a good time to say when there is some connection to research, and that research says that that particular kind of event is more likely to occur because of climate change. But I would be very careful to, unless there's a specific study that came out about a specific event, which, you know, usually you can't talk about that in a live weather forecast because that work has been done until looking back at it. You know, there are attribution studies of particular storms that have been done or particular events that have been done that can say, you know, this event was 60% more likely because of climate change, things like that. But it would be tough to do that in time on a TV weather forecast, I think.
What is some of the current research you're working on? I know we're talking a little bit about weather whiplash, which I think is going to happen in Texas pretty quickly as temperatures warm there into the 60s later on this weekend.
Yeah. So what I've been having the most fun working on research-wise lately is that weather whiplash. But before that, we've been looking at whether we can see evidence for weather systems becoming more persistent, because this is kind of the bottom line of what we expect to happen as the Arctic warms so fast, as the zonal winds of the jet get slower, as potentially we see these wavier patterns in the jet stream happen more often. Those big Rossby waves, when they are big, they tend to shift very slowly. So we've been trying to come up with new ways to measure weather persistence. And we're doing that based on a large scale circulation pattern technique. So it looks at, you know, like the whole North America plus, you know, half of the Pacific Ocean, and using a clustering type tool, basically decomposing the atmosphere's patterns into the characteristic ones that tend to occur. based on daily data. So we use the entire 72 years worth of, say, the NCEP reanalysis data set, and we find these characteristic patterns. We can determine how many of them we want to consider, but typically we take about 12. And then we can look at how often the atmosphere gets stuck in one of those patterns for, say, 4 or more days in a row. And then keep track of how many of those events happen. We call them long duration events. So we've actually had 3 papers already published looking at this way of measuring persistence. And we are finding that the patterns that have a very warm Arctic are the ones that are having more of these long duration events in the past, and also looking at model projections for the future. So it's been really interesting. And then, as Chris mentioned, we have been kind of extending that idea to when we have one of these long duration events, one of these very persistent events, what happens right after that? Does it flip to a whole nother pattern, which is something we would call weather whiplash? And so what we've been doing is taking those long duration events and then seeing what happens 2 days later, seeing how different that pattern is 2 days later. And when it's very different, and we've got kind of a metric for measuring how different a pattern is, then we call that a weather whiplash event. And so that's what I've been having the most fun with lately. We just submitted a paper to the Journal of Climate with our just sort of proposing this as a new metric for weather whiplash. We were focused on just the winter in North America and the Eastern North Pacific, that kind of region there. And it's been really fun. It's something completely new and different. And in the nutshell, what we found was there hasn't been a huge change in the recent past so far. But when we look at the model projections for the future, we see big increases in weather whiplash events, especially for those warm Arctic type patterns. So it's been pretty exciting.
Can you speak on some of the work of your colleagues? What are the areas of expertise? I mean, I've used a lot of your scientists for rising sea level, but what other areas of the science do you focus on?
Wow. So in my work with more public communication type of focus, I've been expanding more to think about all the different ways that climate change could be influencing extreme weather events. So not just the Arctic, more generally, how the changing climate system is affecting extreme weather. And also thinking about how the Arctic, not just through the jet stream, but how all these other ways that the huge changes that are happening up there are affecting the climate system, the large scale circulation, exacerbating global warming, making sea level rise accelerate. There's a lot of things that are happening in the Arctic that are affecting many other parts of the climate system beyond just, my weather interest. So, kind of trying to broaden it more, even thinking about, how tropical storms might be influenced by what's happening in the Arctic. So that's been a really fun avenue as well. It's a real opportunity for some science communication because that's what people are thinking about, talking about, being affected by in very detrimental ways often. And so it's kind of nice to have some other stories to tell when some of those other kinds of events occur.
In your time in doing this and as a researcher, we receive a lot of pushback. And it's interesting, I did a story on renewable energy that aired last night with what's going on in Texas. I thought it was important with the wind turbines and clearing up that misinformation. Do you suggest engaging with people? And when is the right time to just say, you know what, it's not worth our time and trouble? I've found personally that if somebody's willing to listen and keep an open mind, to try to explain the science to them. But do you have any suggestions with that?
Mm-hmm. Well, I agree with what you just said. Some people come at you And they might ask what seems like a reasonable question, and then you answer that question, and they are just hard over with what they believe is the answer, and they're just not willing to listen, and they don't have an open mind. And as soon as that's apparent, then I'm like, okay, well, don't ask me then if you don't want to listen. But that's a relatively small fraction, I would say, of the public. Most people really do want to hear from a credible source, like you all, like people like me who are actually down in the ditches doing the actual research and publishing the peer-reviewed papers and things. So I think it's definitely worth engaging, especially if that person demonstrates some willingness to listen to a different perspective, or just listen, period. They might not have a perspective yet. So, and that's the large majority of people, I think, especially now. The things have changed so much. They've seen with their very own eyes these crazy events that have occurred. They've felt it, maybe their own property or their own family or their own community has been affected by it. And thanks to you all, and thanks to a lot more good communication that's been out there, I think, a lot of the misinformation, disinformation has been refuted with a lot of really good communication tools. So, I think we've made a lot of progress. There's still a long way to go, but I'm feeling quite optimistic about that.
Have you seen where there's political common ground? Are there issues in climate change that seems like both sides of the political aisle are on board with more than others to maybe spark conversation?
Well, the great common denominator, I think, is money and lives. It makes a lot of sense to address climate change in a proactive way because it saves a lot of money. And when that can be demonstrated, and that I think is a whole nother area of research that's been helpful, is connecting climate risks with how it's going to affect our economy, financial implications. Businesses are certainly getting on board. We're seeing that at Woodwell big time. They're coming to us asking for information that's going to help their business make better decisions because they have assets that are vulnerable in some places more than others. And so, I think a lot of people are really constrained by their financial situation. And so when you can explain that, this is going to affect your wallet, it's going to affect your personal property, it's going to affect your insurance rates, it's going to affect your mortgage, whatever it is, then people really start to listen no matter what side of the aisle they're on.
I know a lot of news stations and news coverage looks at the tipping point. What are some of those telltale signs that you're looking at as a scientist that have we gotten to a point of no return? Is it worth focusing our attention on that? Is it better to focus on some of the positive work that's being done, or maybe a blend of all of the above?
So I know the term tipping points has gotten a lot of attention, and it's kind of a nice concept for people to grasp onto. But I think in the physical climate system, there are really very few true tipping points. You can, when it comes to physics, you can pretty much always bring something back from, a direction that it's been heading in. I think the true tipping points in the climate system are actually not the physical side, they're in the ecological side. I mean, there comes a point where species of plants or animals just cannot live in some location anymore, or their habitat is gone. And those are true tipping points, because once you've lost a species, once it goes extinct, it's not just that species that's affected, it's that whole food web that it's part of, and it disrupts the whole ecological system. So in my mind, in talking about tipping points, there's a lot that we really don't understand because the biological cycles are just so complicated. Many of them are not understood even in their present situation, never mind in this rapidly changing habitat and environment that they're trying to deal with right now. So I think a lot of the surprises that will come out as we go forward will be more in the biological, ecological side of the ecosystem, of the climate system.
I want to get to everyone's questions, and if you want to start opening up the chat, Eddie, I saw that you posted, and I'll get to that next because I want you to have the opportunity to ask as many as you can. With sea level rise projections, Dr. Francis, it appears that there's some research recently that shows some of those models, some of those forecasts are underdone. Even some more of the aggressive models that show, 6, 7, 8 feet of sea level rise. Where is that research going, and what are your thoughts on that?
Yeah, so, just a couple of IPCC reports ago, the melt of the Greenland ice sheet and the Antarctic ice sheet were not considered in the estimates that they put out. We knew so little at that point that, they couldn't even make good guesses. But since then, there's of course been a lot more research. We understand not everything, of course, but we have a much better sense of the fact that melting is happening on the surface of Greenland. It's happening from the undersides of the glaciers that are extending out into the oceans. That melt appears to be happening a lot faster than anybody thought. Same is true for the Antarctic ice shelves, especially in the areas like the Ross Sea and where they've been monitored quite closely. And, everything points to the fact that it's all happening much faster than anybody thought. And of course, when that land ice melts, it becomes part of the ocean. It adds mass to the ocean, unlike sea ice, which is already floating. So it, when it disappears, it doesn't affect sea levels. But on top of that, I think there's also been an underestimation of how rapidly the warming could occur. For example, our group at Woodwell is one of the foremost research groups looking at the permafrost and what's happening to that up in the northern high latitudes. And, that is another process that has not been incorporated into any of the global climate models, or at least if it is, it's very rudimentary. And again, what we're learning just in the last few years is that permafrost is thawing and degrading much faster than most people thought. And when that happens, it's releasing a lot more either carbon dioxide or methane into the atmosphere, both of which are powerful greenhouse gases. And so it's going to accelerate the warming because of the extra greenhouse blanket that we've already put onto the atmosphere, onto the earth. So there's a lot of these processes that were just, either not known enough to put into a model or just completely underestimated. And they're contributing to this acceleration of the estimates of sea level rise.
Thanks, Dr. Francis. We'll start opening up to questions. Eddie Shear in Newfoundland, which he's the one who told me it's not Newfoundland, mentioned that blocking has been a staple pattern over the North Atlantic this year, largely keeping Arctic air out of northeastern Canada, like northern Quebec, Newfoundland, and parts of Labrador have had their warmest January on record. Ice has been slow to form along the coast of Atlantic Canada. We're running well below normal. Do you think climate change is leading toward increased blocking, or is the pattern this year just really odd?
Oh, those blocks are a real headache. As you all know, probably our numerical weather forecast models really don't handle them very well at all. They're pretty poor at forming them, and they're pretty poor at breaking them apart. Once they're there, it's great because they last a long time, and then the forecast is pretty solid because things aren't going to change much. But getting those to form and dissipate properly in a numerical model are really tough. I personally think that based on my own research that blocking in the Northern Hemisphere is most likely going to increase. And it goes back to this weakening polar gradient because of the Arctic warming so fast. And by doing that, it's weakening the zonal flow. And we know that when that zonal flow is weak, it tends to be more easily deflected north and south. And we tend to see these more erratic swings, troughs and ridges. And when that happens, it just seems kind of logical that you'd form more of these blocks. I mean, that's way too simple. There's a lot of very complicated dynamics that goes into forming those blocks. It's all non-linear, and that's partly why the models have struggled with them so much. But there's research that goes both ways. Some models suggest that they're actually going to get fewer, and that makes a certain amount of sense because we know there are more blocks in the winter when it's cold, so that if the climate is warming in time, then one might think, okay, then there's probably going to be fewer blocks because winters aren't going to be as warm. But there's also competing influences that are the opposite, like the one I just described with the weakening of the zonal flow. So I think the jury is very much out on that. Right now, it's kind of interesting. I'm working on a new proposal for a project that is actually not going to look at blocks, because blocks have already had quite a bit of research done on them, even though it's still relatively controversial. But we want to look at the other kinds of cutoff features, so like cutoff lows and cutoff highs, which have received almost no attention in the literature, which is kind of amazing. And they cause a lot of very disruptive weather conditions, as you all know. When you get a cutoff low sitting off the west coast of Southern California, say, they're very unpredictable in how they move. They create a lot of convective activity along their eastern boundaries, and very little is known about how they form and how they behave. So it's not just blocks, it's these other cutoff features that I think are going to be really interesting to take a look at.
All right, thanks, Eddie, for that question. Ada has a question about Saharan dust events. Last year we had the Godzilla event, and this year we're already measuring Saharan dust. Any thoughts on this?
Well, I mean, we know that whole northern section of Africa the desert is growing. It's getting drier, it's getting hotter. So it kind of makes sense that, that more dust would get put into the air. And we know when it does, it causes some interesting impacts. It's actually one of the things that will prevent a tropical storm from developing. When there's a big dust layer, big Sahara dust layer, we tend to see suppression of tropical development. But that dust also is a real fertilizer for the ocean. And you've probably heard and read and maybe even seen the big increase in sargasso weed that's been forming in the tropical Atlantic. It's been washing up on the beaches of the Caribbean islands and the Bahamas and Florida, and it's making just a horrible mess. It's having a huge impact on the travel industry in those regions. And it's thought that the dust from the Sahara is settling into the tropical Atlantic and really fertilizing that sargasso weed. So, like I said, the living part of the system is where the surprises often come from. And I think that dust might be related to some of that.
Thanks, Ada, for your question. And this is from Bernadette. Hello, Dr. Francis. Thanks for this conversation today. Curious to hear what has surprised you most in your research. And in your opinion, what are some of the most untold climate stories?
Wow, that's a good question. So, what surprised me most? I guess it's not so much what we've learned research-wise, it's more how it's become such a public discussion topic and such a controversial topic among my colleagues as well. I never imagined myself talking to a group of people like you or doing interviews on TV or NPR or whatever to talk about my work. I just never imagined that's where my career would go. So it's been a real surprise to me to have for my work to have gathered so much attention. Really, that's been the biggest surprise. Some of the most untold climate stories. Well, I think it kind of goes back to what I was saying about the impacts on the living part of the system. You know, there's still a lot we don't know. We do hear more stories now about, say, the turtles along the Gulf Coast right now that are they're trying to rescue these sea turtles that are trying to survive in the sea surface temperatures now that are in the 30s, that they're just not adapted to deal with. And I think, you know, these events like this are pushing their environments to the brink, where so many different types of animals just cannot cope. And so I think those sorts of climate stories, if you think of the climate system as including all of the living things, that would be one of them. And I think another big climate story that's really starting to get a lot of attention now is, you know, these disruptions in the stratospheric polar vortex. We've heard polar vortex a lot lately. Well, in the last few years, really, is the first time that it kind of hit the mainstream. But I think people are still really don't know what the polar vortex is. And I'm always very careful to use jet stream for the jet stream and polar vortex for the stratospheric polar vortex, because otherwise it just gets way too confusing for everybody. And I think, you know, how that stratospheric polar vortex, you know, we don't have really good models for simulating that. Again, it's another one of these not well understood set of dynamics, the processes that can disrupt it, what's happening in the climate system that can trigger those disruptions in the stratospheric polar vortex, like we saw this year, which was just, you know, a magnificent example that went on for a very long time. Or it looks like it actually was 3 disruptions kind of back to back, which is a very unusual thing to see. And of course, when that happens, we get all kinds of crazy extreme weather events all around the Northern Hemisphere. But okay, so what was different about this year, where we had that incredible disruption, compared to last year, where we still had very low sea ice? The Arctic was quite warm, at least in the beginning of the fall, but yet we had one of the strongest stratospheric polar vortices we've ever seen. And as a result, you know, most of the northern hemisphere was pretty mild, and it was very warm. So I don't think anybody really knows yet why those 2 years, which had a lot of commonalities, there was a La Nina, you know, why were they so different when it came to the stratospheric polar vortex? So I think there's a ton of work that needs to be done there. You know, most of the climate models really have pretty poor polar vortices and the dynamics associated with them. Chemistry comes into it. I mean, it's really complicated. So I think that might be where some of the really interesting new research is going to come from.
Thanks, Bernadette. And this is from Matt, Dr. Francis. Good to see you again. Has there been any research attributing the North Pacific blob to anthropogenic global warming?
So you mean causing the blob in the first place? I mean, the oceans are warming generally. We've been in a positive Pacific decadal oscillation since late 2013. The blob and the PDO are kind of connected to each other. I mean, I'm not a physical oceanographer, so I am not sure whether a physical oceanographer would say that they are different entities, or whether the PDO being in its positive phase now is just exacerbating the fact that the oceans are generally warming, and we're seeing it even more strongly in that area. But that said, I think the fact that we do have all that warm water sitting off the west coast of North America there is having a huge impact on the general tendency for how the jet stream has been behaving across North America for the last several years. And the general tendency has been for a ridge somewhere along the west coast. It kind of drifts back and forth from, say, over the Sierra Nevada out to south of the Aleutians, say, but there's been this very general tendency for a ridge to be parked basically where that warm water is, and a general tendency for troughing to happen downstream of that. And so what we're learning, there's been a couple papers, is that when the ocean temperatures out in that eastern North Pacific area are warmer than normal, and it tends to put a ridge in that general area, and we combine that with the fact that the ice is being lost up north of Alaska. It's one of the areas where the ice is disappearing the fastest. And as a result, the Arctic Ocean in that area is also one of the warmest areas. So that ridge then can tap into that extra heat that is due to climate change, and it makes that ridge even stronger. It elongates it more in the northerly direction, and thereby makes it more persistent. So we think this is one of the reasons why this pattern has been really quite persistent, leading to this multi-year drought in the Western states, you know, not consistently every single month, but overall for sure. And so, yeah, so I don't know exactly what's causing the blob, but now that it's there, then this is, I think, one of the impacts of having all that warm water sitting out there.
Matt, thanks for your question. So Dr. Francis, this is from Spencer. How is climate change affecting aviation? I've heard more than a few pilots say they're encountering more frequent and more severe clear air turbulence, and they attribute this to greater instability resulting from a warming atmosphere.
Yeah, there's been some new work on that actually, and it seems to be true that that turbulence is increasing. There was a new paper came out just a couple years ago, and I'm trying to remember exactly how it went. And it is related to the differential warming at the surface and aloft, creating generally more turbulence in the atmosphere. I'd have to go back and review that paper, but there have been a couple studies suggesting that is a real thing.
So let's address the elephant in the room that's going on in Texas. I think a lot of people are going to be covering it again tonight. And are there any ways to, I guess, attribute it to climate change that's simple, not over the viewers' heads, that they can understand that, yes, it is cold, yes, it's snowing, yes, there's ice, but yes, it's also climate change?
Yeah. Yeah. So, I mean, there's some things that we definitely know, right? We know the Arctic's warming really fast. And so when we get an Arctic outbreak, that air is actually going to be warmer than it would have been a couple of decades ago. We know that we're breaking way fewer cold temperature records in the last couple of decades than high temperature records. And that's totally expected. As you shift the mean temperature of the Earth towards the warm direction, then you expect, that's exactly what we'd expect to see. And that's exactly what's happening. That said, we can still get these outbreaks of very cold air. The Arctic is going to have ice in the wintertime for a very long time. And it's still going to be dark up there for 6 months of the year. So we are still going to be developing Arctic cold air masses there. And sometimes when we're in one of these very wavy jet stream patterns where the jet stream dips way far south, it's going to allow that Arctic air to plunge way far south. And when it does, you know, places like Wisconsin and Minnesota are totally equipped to deal with it. And it's, you know, it gets cold, very cold there pretty much every year. But when we get one of these extreme troughs where the jet stream dips way far south, whether it's Florida or a place like Texas, it's going to be extremely disruptive to those places that are not used to having that kind of cold. Of course, we've also compounded that with the ice storms and snowstorms, but you know, those go hand in hand. When you get a big trough like that, you've got a big clashing of the tropical Gulf of Mexico air meeting up with that really cold air in a very southerly latitude. And so you got to expect to get some, you know, a lot of icing and that kind of wintry mixy stuff. So, this particular winter, we get these excursions of the jet stream naturally, but because of this huge disruption of the stratospheric polar vortex that we had occur this year, which was really quite amazing, actually, some of that cold air from the stratosphere, instead of being parked up over the North Pole where it usually sits and doesn't bother anybody, instead was shoved southward over the North America. And so that has reinforced that Arctic air mass at the surface and made it that much colder and probably made it plunge that much farther south. So, climate change comes into the story in two ways. One is the sort of opposite of what we're seeing right now, which is the idea that we're actually warming winters overall. Average winter temperatures are increasing. We expect these Arctic blasts to be less cold in the future. However, there's also evidence now that these disruptions of the stratospheric polar vortex may happen more often in a warming world. And there's a complicated set of mechanisms that have been proposed, but there's more and more evidence now to suggest that this is actually already starting to happen and will happen in the future. So there's those two aspects of how climate change kind of come into what we're dealing with right now.
A shout out to Jessie Ricka with her mask. I got the mug and my coffee cup, but I like the mask. I love it. Love the warming stripes.
I saw some really good socks on somebody the other day. I got to get a pair of those.
Eddie asked, we know that storm surge events are picked up relatively well in the lower 48. As an American living in Canada, I'm astounded at the lack of recorded data, particularly sea level data, Environment Canada seems to record. Do you think there are more storm surge events happening throughout North America than we know about?
Absolutely. It goes sea level rise. I mean, it's just kind of a natural extension of sea level rise. Sea levels are rising, and so when a storm comes along now versus a few decades ago, that storm surge, I got a tropical downpour happening here. My computer over a little bit. Then, any storm that comes along is going to be riding on a higher ocean. And so it just goes without saying almost that, storm surges are going to be worse. Compound that with the fact that storms are producing more precipitation now than they used to. So there are places where the land flooding from rainfall will be meeting tidal flooding, and especially in low-lying areas, those two will combine into many more coastal flooding events. So we do have sea level data pretty much all over the world now from satellites. They're doing an incredibly good job of that, even without having the sensors in situ. So we have a pretty good sense of how sea level rise is changing all over the globe. And as you know, it's not even. There are places that are rising much faster than others for a whole pile of different reasons. So in fact, all along the East Coast is one of the places where it's rising the fastest.
I have a question. It seems like this winter, especially in Boston, the rain snow line has been impossible. It appears that there's that change to rain, and the amounts fluctuate from 2 feet from 128 to an inch at Logan Airport. Do you think you can attribute that yet, or is there not enough data to climate change and warmer ocean water, since the North Atlantic is warming so quickly, especially the Gulf of Maine? And will that just continue to be a big challenge for us forecasters in the Northeast?
I grew up almost on Cape Cod there, in a little town right on Buzzards Bay, and it's been a problem, an issue, a forecasting issue for as long as I can remember. That rain snow line has always been very disappointing as a kid hoping for a snow day. To know that 5 miles away they got 8 inches of snow and we just got 2 inches of slush. So I think it's nothing new. Certainly we're expecting coastal storms to produce more precipitation. We know that. You can measure that. When it rains, it pours now. So when it snows, it's probably going to snow more. But, you know, as we warm the oceans, as you say, and as we warm the atmosphere generally, most likely that rain-snow line will get pushed a little farther inland and farther northward as well, just through the warming.
Excellent. And if you're not watching the chat, as Heather mentioned, Dr. Francis lives part of the time on her sailboat. She's very passionate about sailing and is in the U.S. Virgin Islands. Had an interesting time getting back, I know, during COVID, during last winter. But I guess when you're dealing with a rain snow line and deal with tons of disappointment on Cape Cod, you just want to give it all up. Thanks everyone for joining. I'm going to send it over to Alex. But again, it's more than just the scientists there. Woodwell has terrific policy experts as well. I've done stories on policy, which is important when we're looking at mitigation and adaptation and funding it and seeing where the policies lie. Those are important stories to tell, and their experts really cover the spectrum, and they get back to you quickly. And that is always appreciative in our world when we're working on tight deadlines and we have more shows and more content to fill than ever before. So thanks for joining. Alex, I'll turn it over to you.
Sure. Well, thank you so much, Dr. Francis, and thank you, Chris, for facilitating this today. It was a great conversation. And I think for us, it was really the start of trying to do more of this. And I think we're really eager to hear from all of you. You'll be getting an email from me on the back end of this. If you have ideas for future sessions that, we're happy to also make them sort of focused on specific, geographical issues you might be facing. We have a lot of different experts we can pull from. I think we're eager to stay engaged and find ways to keep working on this. So I hope you found this valuable. I know we were going big and broad for this first session, but, have the ability to get a little bit more specific on things too, if that's of interest. And as Chris mentioned, my responsibility is to be the person that connects you. If you need sources, if you need just background conversations or folks for interviews, I will raise my hand to try to turn that around as quickly as possible. So you've got my contact info. I will put my email address in here. It's always the best place to get me. I just dropped that into the chat now. And, other than that, I just really want to thank everybody. I know you have so many different things going on in your life. So being able to join us for an hour at lunchtime, I know is not easy. We have recorded the event, so I'll send around the link. If you have colleagues that you think might like it, or you want to just refer back, as I said, it's fully on the record. So if you need to quote any of it or anything like that, no problems there at all. And just thanks for this sort of our inaugural voyage on trying to do something like this. So grateful that it came together and hope it was useful. And we look forward to having you join us in the future. Good luck with all your coverage and with covering tonight's show. So thank you very much.